Hi everyone, and welcome to our talk on serverless Azure in the enterprise. Let's see if this resonates with anyone. You've learned about serverless and you've done some proof of concepts. You get a new project and it feels like a great fit. You're super excited. You book a meeting with the architecture team, IT and security. You explain how great serverless is. It scales infinitely, it has per second billing and no resting cost. High availability and disaster recovery are simple. Logic apps are going to remove the need for writing your integrations, and you're just going to be so much more productive. As you're doing your explanation, though, you realise you're getting blank stares. The reason that this conversation doesn't go so well is often that the person on the other side of the table has different priorities to you as a developer. Their priorities might be uptime, security, or ongoing maintenance. They may be thinking something like, if all this stuff is internet facing and anyone can hit the endpoints, I'm not okay with that risk. Or, how am I going to monitor and secure this thing? It sounds like a lot of small pieces and that's going to be a lot of work. Or commonly they're concerned that their business as usual work already has them at capacity, and this sounds like a lot of new things to learn. We hear about this all the time. What these meetings usually end with is a plan that, well, because we have a short time frame, let's just do it the old way. Contrast this with a dev who comes into the meeting and says, well, really, this workload is really event-driven, so we're going to use a serverless programming model. Depending on the project's needs, we can either deploy this into a highly controlled environment, even something that's PCI or IRAP protected certified. Or we can leverage super scalable, really cheap serverless compute. Or we can choose an option in the middle. Can we get together to find the right balance of control, scale, and cost for this project? Reframing the conversation this way is much more likely to lead to a positive outcome. If you want to get traction with serverless in your organization, the key is to ensure that the other teams you're working with understand that the serverless paradigm doesn't mean that they can't also meet their goals. Hi, I'm Adam Stephensen. I work for Microsoft as an Azure specialist. My job's to work with state, governments, financial institutions, and large commercial customers and help them architect and deploy workloads on Azure.
Hi, I'm Duncan Hunter, and I also work for Microsoft as an Azure specialist here in Sydney with financial and government customers. But I don't just have a bunch of experience with Azure Serverless. I've also got a bunch of experience shipping and maintaining serverless apps with Google Cloud Platform and Firebase.
Look, Duncan and I are here doing this talk because we're working with enterprise, public sector and commercial customers every day doing serverless. A few years ago, serverless was being talked about and had traction in smaller companies, but didn't have widespread adoption in the enterprise. That's all changed now. Nearly every customer I work with is leveraging serverless in government, in banks, in commercial. That's why we're here today. We want to help you add value to your organization by sharing our experience with serverless in the enterprise. Serverless is such a broad topic and there's lots of different interpretations. Duncan and I work on the same team and on the same technologies, but when we started to work on this talk together, we had several conversations coming together about just what our definition of serverless is. What we've agreed upon, for the moment at least, is that serverless really has three aspects. The first relates to an event-driven programming model. The second relates to a hosting abstraction where the developer doesn't need to worry about the underlying compute and their code is executing upon. And the third is that you only pay for what you use.
But the part we discuss the most is pricing, because I feel that for something to be a serverless service, it really needs to only be charged for the amount of compute you do or the amount of time that actual service is running. So for me, a classic PaaS service like an Azure App Service Plan that you'd run a normal API or app on is not serverless. It might be serverless in the sense that you don't manage the servers, but it's not serverless in the sense that you have to pay for it no matter whether or not it's doing any work. And I have a bunch of colleagues who just call everything, Azure PaaS now serverless, and I cringe. But I feel like our definition of serverless is shifting in the community. And for example, an app service plan now has got some work starting in the background to have, a scale to zero option similar to other sort of options you get in Azure around, say, SQL DB now has a serverless offering, and Cosmos DB, and of course, Azure Functions. So I'm guessing this kind of trend just to call everything PaaS serverless now, and it's all becoming serverless, will continue. But what's really interesting is that more and more PaaS offerings are offering a serverless tier.
And I find this conversation really interesting, and I love putting the challenge out and saying to people, well, an Azure function running on serverless compute is definitely serverless, but what about an Azure function running on a Kubernetes cluster? Is that serverless? Or what about an Azure function running on a virtual machine? If the developer works in an event-driven manner and doesn't have to worry about the underlying infrastructure, isn't it serverless? Before we talk about where we're going to cover what we're going to cover, I just want to call out that this isn't a 101 serverless talk. We aren't going to cover all the benefits of serverless and how to get started. There are many, many, many talks covering those topics. We want to talk about what we're seeing in the enterprise, the techniques and patterns that we're seeing and that are being successful, and some emerging trends.
So we're going to start off with a look at how we would build the perfect serverless architecture today, and then we'll check out all the components that make up that, and then we'll share with you the open source projects that we're building and collaborating on to make building a serverless starter like this minutes versus hours.
And then we're going to look at the reasons why a lot of our customers just can't deploy that purely serverless multi-tenant application, and the patterns and architectures that compromise between the pure promise of serverless and the real work requirements of the enterprise. We'll look at patterns and architectures that can keep CSOs and IT admins happy with their security requirements all the way up to protected. We'll have a look at how to leverage serverless and still have a multi-cloud strategy, and how to leverage the benefits of containers in Kubernetes and serverless at the same time.
And finally, we'll have a look at a few real-life implementations of serverless we've done with customers. So let's have a look at how we would build the perfect reference serverless application today. Now, we're going to start here as a starting point. This is actually not what we see in the enterprise with serverless. So in the following sections, we will look at what stops kind of customers doing this serverless setup that I'm about to share with you, and also demonstrate this similar architectures, but with different levels of security. So the entry point into your serverless APIs or any of your applications should be Azure Front Door. Azure Front Door gives you a global, scalable entry point running on Microsoft's global edge network. And it really wraps up three services. It wraps up a WAF or a web access firewall. Second is a load balancer to route traffic to different regions. And this is similar to the Azure Traffic Manager, but we kind of believe that the Azure Front Door really replaces that for a lot of people. And third is it acts as a CDN, caching your static assets on the edge for faster content delivery. The other cool thing that's good about Azure Front Door is once your request hits an Azure point of presence, it's going to travel over Azure's backbone versus the public internet, making your requests even faster. Any of your requests to your APIs should go via an instance of Azure API Management, also running on a serverless tier. And API Management is the gateway into your APIs to help accelerate your API development for both internal and external APIs. And of course, you could just expose all of your APIs individually yourself, but we believe it can help avoid the chaos of having many different parts, many different team practices and security practices, and sharing those APIs. So we really believe it's a best practice for your serverless workloads to use API management. For your APIs, you could leverage Azure Functions, also running on a serverless pricing tier. And hot off the press is that now they're in public preview, is you can run logic apps on the Functions runtime, which means that you can run your logic apps in a function app or in a container. And if you haven't seen Azure Logic Apps, they're Azure's serverless workflow solution, similar to event-driven functions, except rather than writing code, you drag and drop logic onto a GUI. So this is what an Azure function looks like, written in C#, but you can write them in many languages. You don't need to really read this code. The idea of showing you this is more just to say that they're small event-driven blocks of code like this that you can scale up on demand and scale down to zero, or even keep a single instance warm. But we'll talk more about that later. This is what an Azure Logic app looks like in the upgraded designer, running in VS Code offline. And as I mentioned, they're similar to functions, except you design them in a GUI, and they're much more suited for connecting lots of different workflows together and multiple services. So there's a heap of different places you can actually run an Azure function, or how you can host them. You can put them in a consumption plan. You can run them in an app service plan where you would normally put an API or an app in a PaaS style. You can run them on an app service environment, which is like an app service plan, except you get dedicated resources and network isolation. And you can run them on premise with Azure Stack hardware, and you can run them in a container. So that means you can run them in Kubernetes, and you can run them anywhere. You can run them in another cloud. You can run them on premise, wherever you can put a container. And you can also run them on a device with Azure IoT Edge. So we used to joke a whole bunch that, serverless doesn't mean that there's no servers. It just means that you don't manage them. But now you can see from this list that you can run serverless on the servers that you do manage. So I think this desire to see people want to host their own serverless parts is because they really want to leverage that event-driven paradigm, that programming model, so that they can have more scalable apps, but also to encourage making microservices over monoliths. But it's kind of adding to this challenge again of being able to say exactly what serverless means to everybody. And as I mentioned, Logic apps in public preview for running on the function runtime. So anywhere you can run a function, which is pretty much everywhere, you're going to be able to run Logic apps, which I think is pretty cool and a pretty significant change. So backing these serverless functions and Logic apps in a perfect serverless architecture, you could have Azure Blob Storage and Azure Cosmos DB. Azure Cosmos DB is our globally distributed NoSQL horizontally scalable database, or just basically it means it's a modern database that you can run in multiple places, and currently has a serverless pricing tier in public preview also for the SQL querying API. And it's coming to the other querying APIs like MongoDB pretty soon. And this combination of blob storage and static assets and Cosmos DB for querying your more complicated data will pretty much cover most of your data and storage needs. Now, Cosmos DB being designed to globally distribute makes it easy to geo-replicate across different regions. And API management and functions and Logic apps all have a serverless tier, which not only make them an ideal choice for doing a serverless setup like this, but it makes deploying them to multiple regions really easy because you only pay for what you use. So it doesn't matter if you deploy them into lots of different regions, you're still only going to pay for what's being used in those regions. And it not only makes it trivial for being able to deploy to multiple regions and being able to do an active-active model for faster disaster recovery, it also means you get that same ease of deployment for all of your other environments, be it dev, pre-prod tests, whatever you call all of those different staging environments, and also for being able to do blue-green deployments to incrementally roll out your APIs. So awesome here. Also down on the bottom left here, for good measure, would throw in Azure Monitor for being able to get good observability. Would throw in Azure Key Vault for being able to securely manage your keys and certificates. Would use GitHub for being able to do your Git repos and your CI/CD and your pipelines, and also Azure Active Directory. Not only for being able to secure, your requests coming in from users to access your APIs, but also for being able in development to secure between your services with managed identities, so you don't have to go through the pain of dealing with password and certificate rotations. I'm going to do a bit of a small shameless plug here. We're actually currently building this architecture as an open source serverless starter with some of our partners like Insight in Sydney and Brisbane. So if you're interested in joining us in building this, then reach out to us via this repo. I would love to have you come join us. So this is kind of super awesome, best practice, pure serverless. But there's one thing here that's missing that we see all of our enterprise customers need, rightly or wrongly. So I'm going to hand you over to Adam to discuss what that is.
So, what's the big challenge to doing serverless in the enterprise today? Well, it's control. A perceived lack of control is the number one technical challenge that stops customers implementing PaaS and serverless in the enterprise. And it's not too hard a conversation to start having with your organization, though. In Australia, ASIO uses Azure for secret workloads. The US Department of Defense is putting billions into their Azure platform. We have docs on how to build web applications up to an Australian Signals Directorate IRAP-approved protected architecture. And we've also got architects for financial services companies like banks that's PCI DSS certified. Banks, federal and state governments, and security organizations are trusting sensitive workloads to PaaS. In organizations that have trust issues, I find starting from a place of safety is best. That's why I love these reviewed and approved architectures. They let us have conversations about the sensitivity of the applications we're building. A good question to explore with your company is sometimes, if banks and government departments can host sensitive workloads on PaaS, why can't we? As I tried to portray at the beginning, the issue is often how the developers introduce new patterns and technologies to their organizations, and that often what often determines their success. I often say to developers, if you want to use serverless, you need to advocate the full serverless security spectrum and the network patterns inside your organization. The architects and the security team want to see, how do we apply network controls? How do we do monitoring and locking? What uptime am I going to get, and how much is it all going to cost? I explain the serverless computing spectrum to them like this. We can take our serverless functions and deploy them on isolated compute, just like the PCI and IRAP blueprints. What happens in these isolated tiers is that virtual machines running under the covers, both for hosting the web applications and the control planes, are dedicated to you, and they're running your own private address space. You get all of the control, the full control and network isolation, but of course, you're also paying for a lot of that reserved compute. On the other end of the spectrum, you've got the full serverless compute model. Most presentations and demos on serverless are focused on this. You're running functions on the consumption plan, only paying for what you use, not having any resting costs, scaling almost infinitely, and deploying with agility and flexibility. But you're getting pushback because every Azure function and logic app has a public URL and IP address, which, even though it's secured using authentication and authorization, it raises the hair on the back of security professionals. And where I want to spend some time with you is helping you with the technologies that land you somewhere in the middle ground to give you the best of both worlds. If we use premium Azure functions, we get a few great benefits, like we can avoid the cold start issue of serverless, we get more proactive scaling, and we get additional network capabilities. These network capabilities allow us to lock down all access via the web or public IP addresses to our services. And this is the sweet spot that we're working with many customers towards. It meets the requirements of the IT pro and security teams and still gives developers all the benefits of serverless that they're chasing. So before we can look at these different architectures, I just want to do a little bit of a level set. And what I've got on the diagram here is a normal Azure function and logic app. By default, both of these are accessible from the internet as long as I'm correctly authorized. For example, I can get the URL of my Azure function and put it in my browser. And this is a cause of concern for some organizations. Once again, this can absolutely be secured, but either because of regulatory requirements or else a desire to implement the same network isolation-based securities policies that they apply on-prem, many organizations want their web apps and function apps and logic apps to be completely isolated from the internet. Now, IT pros have been isolating workloads from the cloud for ages. It's what they love to do. The short version of how they do this is that all websites have a numeric address called an IP address. And there's a few special ranges that just don't work from the internet. They're reserved for use inside, work and home networks. And they often start with 192.168 or 10. For our demo, we've chosen 10.1 to start all of the addresses for our on-prem network. We've also created a private network space inside our Azure cloud. And let's assign it all the addresses that start with 10.0. Everything inside this 10.0 something private address space isn't available at all to the internet. but it is able to be connected to from the on-premise private network. This provides additional security to our internal resources. There's no way to access our private IP address space from the internet. Now, once we've got that private network space, we can carve it up into smaller networks called subnets and reserve some blocks of IP addresses for different purposes. So I've created two here, one to put web apps into and one to put our API gateway into. These tools are the security tools that IT pros have been using for decades. They're familiar and are what are going to bring a sense of comfort to that IT pro and security teams. Now we've got our private address spaces and we've got them locked down and controlled by firewalls, we can create our web compute and our API gateway resources inside those subnets. Everything needed to run our API gateway and the compute for these functions is deployed into the private address space. It's worth noting that the API gateway here isn't actually an API that's executing. It's an abstraction layer over the top of the actual APIs that let you manage security, performance, and admin tasks related to the APIs. Now, because these isolated services only have an internal IP address, there's no way for them to be accessed except from other IP addresses like on-prem. If we did want controlled internet access to these resources, we have to put in a load balancer and firewall that straddles that virtual network and allows us to create specific rules about what gateway to allow into our private network and where it should go. What we've done now is we've essentially recreated the core of that protected or PCI architecture. What we're missing from our original diagram, however, is our data stores. Now, let's put on some Azure Storage and Cosmos. Let's put the Azure Storage and Cosmos from the original use case in. Now, because these services are based on massive shared infrastructure, there's no mechanism to actually deploy them inside our private virtual network. What we do instead is we use the private link feature. With private link, we can block off all internet access to our multi-tenant services and create an entry point with a private IP address that becomes the only way to access those services. These services are no longer accessible from the internet, but they are accessible from our private resources in the VNet and from on-prem, if we have the firewall rules configured to allow it. Now, I know it's networking, and usually networking is not too exciting to developers, but private link's a really big deal. It's the feature that allows us to talk to the security teams and explain that we can have network isolation of public PaaS services. It's absolutely essential to enabling serverless in your enterprise. So this is the solution that a lot of our customers start with. It gives them enough control and security. It has enough control and security for nearly any organization. Look, it has downsides though. It is more complex to deploy and it costs a lot more than running the pure serverless compute. The conversations we're having with many of our customers is how to move those web applications, functions, and logic apps out of their private network and instead run them as multi-tenant services, but still have that nice level of network control. This is going to be much cheaper, it's going to be easier to manage, and it's going to give them all the benefits of a pure serverless solution. Now, the challenge with this is that we've secured our data services using private link, but the only way to access them is via that private network. Now, this is where another feature called virtual network integration, VNet integration, comes in. VNet integration lets you create a subnet in your private address space, and then your applications are projected down into that subnet. Now, from this function subnet, we can then talk to the private endpoints for our data services. So with private link, you can secure the inbound traffic, and with VNet integration, you can secure the outbound traffic. So that looks great. But can anyone see anyone who cared about network security might raise as a concern? And now, if we're in person, I'd be looking for someone to put their hand up. But it's a bit harder here in virtual mode. But hopefully someone's looked at this and gone, well, we've used VNet integration to allow the functions to talk to the data services, but we haven't locked them down yet. They still have a public address. They're still in this public address space and are still accessible from the internet. So what we've done here is we've isolated those Azure functions as well using private endpoints. So when we look at this overall, our API gateway is in the private address space. It can talk to the private endpoints for the functions. The functions then use VNet integration to talk to the private endpoints for the data services. Now, this gives us the best of both worlds. There's a little bit of complexity, but we're using multi-tenant serverless compute and storage and getting all the cost and scaling benefits. And we've got network isolation as well. The other key challenge we hear from our enterprise customers against running serverless is that it locks them into a single cloud platform. So customers that are looking to stay cloud agnostic and avoid vendor lock-in are focusing on building platforms based on containers. Now, Azure Container Instances are a pure serverless mechanism for running containers. It's amazing how easy they are. To create a serverless container, I can just use the AZ container create command, give the container a name, tell it what image to use and which resource group to put it into, and whether or not to give it a public IP address. That's literally it. So in this demo, the container is a simple web app, and we've said for it to have a public IP address. Once I've executed that command, I could hit that public IP address and the container will be provisioned, it'll execute, and then if that endpoint isn't hit again, it'll be deallocated and will only get billed for the seconds that the compute is actually executing. Of course, the container that we executed could have been any container. And now that we can deploy functions into a container, it could have been a function or even a function with a logic app running on it. Now, look, while this is very cool, the reality is that most container workloads are going to need to interact with other containers, and a container orchestration platform is going to be required to manage those containers. Of course, Kubernetes is the de facto standard now for container orchestration, and all of the cloud providers have a Kubernetes platform. Just like how we can run Azure Functions on Azure Container Instances, we can also run functions in our Kubernetes cluster. This means we can use our serverless compute model, but in our container orchestrator. Where things get really interesting, though, is when you put Kubernetes together with Azure Container Instances. Each of the nodes in this cluster are virtual machines under the covers. What's really cool, though, is that we can create a Kubernetes node that's comprised just of these serverless Azure Container Instances. Now, this means that this node has no resting cost, but when put under load, it'll scale almost infinitely. We then connect it to our cluster using that Azure Container Instances connector, which is powered by our open source virtual kubelet technology. This means that we can run Azure Functions not just on our standard Kubernetes nodes, but run the serverless programming model of Azure Functions on the serverless container compute engine of Azure Container Instances. So when we bring that into our architecture team, this means that getting the benefits of running functions in our Kubernetes cluster on a private network, and that we can also leverage the virtual node technology using Azure Container Instances that can also run in a VNet. This has massive potential for customers. They can leverage the serverless programming models of functions and logic apps, deploy them into a private network environment, and still enjoy the benefits of zero resting cost, infinite scaling, and serverless compute. It sounds too good to be true. And it kind of is. So the issue with Kubernetes is that customers always underestimate its complexity and the need to have a team of experts to manage the Kubernetes platform. So don't let your organization work out how to do Kubernetes. If you want to be successful, we really recommend getting someone in who's done it before. And I'll talk more about this when we get to the customer examples, which is a great segue into our next section.
So now we've looked at the perfect pure serverless reference architecture for building APIs on Azure and discussed a bunch of the network isolation challenges that stop some of these enterprises doing it in a serverless way, we wanted to run through a bunch of different examples and case studies of customers that we've helped in the enterprise doing serverless on Azure. So to start off, we're going to have a look at a case study of a team doing a greenfield set of APIs just using serverless functions. And this case study is the beginning of a trend that Adam and I and our other fellow app dev specialists in Australia are seeing more and more of, and that is companies going all in, writing their APIs, not in a traditional way where they host a .NET or a Node server, and they just use serverless functions. Adam and I probably work like 20 to 30 different enterprise customers each, and I'd say that almost all of our customers are doing some sort of serverless function or a logic app, especially with integration services. But more and more, we're seeing this kind of recent trend to seeing people go all in to do their whole API with functions. So this case study looks very much similar to some of the network isolation we've just covered. They were running function apps with functions for their API, backed with Azure SQL, but they still need to get back onto on-premise to access some of their downstream services. And the company followed a hub and a spoke model setup for their virtual networks. And they did this so that they could have a much higher separation of control between their central IT team or their platform team deployments and their developer team environment deployments. In the hub spoke, they had an Azure App Gateway and a firewall. Actually, they had several firewalls. It was way more complicated than what I'm depicting here. And in their VNet, they had, similar to what we've been showing you, they had private endpoints and VNet integration to be able to plumb all of these things into the VNet to be able to get on-premise, but also to be able to secure them. And to communicate between these two different virtual networks, they used VNet peering, and to communicate back on-premise, they used an express route. So here, I think what's really key is the premium functions. These premium functions have the ability to be able to have a minimum amount of warmed instances so that you don't get any cold starts. And in the past, cold starts have been a real blocker for enterprise people to be wanting to put their most mission critical APIs, onto functions. Also, these premium functions are important because you need to be using the premium functions versus the consumption ones if you want to be able to get some of those network isolation features like VNet integration and be able to use them with private endpoints. The other interesting thing here is that, a lot of these parts are pretty new. This is pretty new setup for a lot of customers. Premium functions are about a year and a bit old. Private endpoints or private link, is only several months old. But this combination of these products allowing people not only to be, able to do cost-effective network isolation and no cold starts, but also I think in general we're seeing more companies, just comfortable with doing serverless. So this whole combination is kind of coming together to lead to this, seeing this more and more common. It's a simple-ish looking architecture. It's becoming more and more common because of these newer capabilities. So I'll pass you back to Adam to talk about some enterprise integration.
So the number one serverless scenario that I'm working on with customers is integration. The complaint I hear over and over is that enterprises have been doing point-to-point integration for years, and now I've got integration environments, that are incredibly complex, that are hard to maintain, and really fragile. The other use case that I hear that I get asked for a lot of help with is customers modernizing big black box integration platforms. In the past, the enterprise service bus, the ESB, it was the gold standard of integration. If you're an enterprise, you had to have an ESB. They're big black boxes that are really powerful, and you can put all of your APIs in and your workflow logic, and you can manage all of your external communications and connections. But the challenges with them is that, they're all the same challenges that we deal with when we deal with monoliths. I'm working with about half a dozen customers at any point in time about moving away from these monoliths and into a modern integration platform that has multiple parts that each do one thing very well. They're able to be developed, deployed, upgraded, and scaled independently, and they cost orders of magnitude less, both in licensing and developing and operating costs. This reference architecture integrates enterprise backend systems using message queues and events to decouple services for greater scalability and reliability. It's got logic apps to orchestrate workflows and no-code integrations. It's using API management for publishing catalogs of HTTP APIs to promote reuse and discoverability. And it's using message queues and events to decouple services for greater scalability and reliability. It's really using small, targeted, independent serverless components all working together to form a complete integration platform. So that's really the number one use case for logic apps. So the number one use case for logic apps that I'm seeing is really this enterprise integration. They're the cornerstone of integration. The customers I've been working with have obviously been running either multi-tenant logic apps or paying for the isolated integration service environments to run their logic apps on isolated compute. But I'm actually working now with several customers that are aiming to go to prod early in the new year once the logic apps on functions goes GA. I'm not sure on the timing on that, but that's their intent, is they're watching that really, really closely. So one in particular is quite typical of these ESB modernizations. They're modernizing a decade's worth of BizTalk services. So they've got multiple servers running BizTalk and migrating away from BizTalk, one BizTalk service at a time. And this isn't uncommon. I'm working with customers moving from at least 3 different ESBs at the moment. And unfortunately, there's no magic sauce. It's a case of taking a thin slice of the services in the ESB, BizTalk in this case, and creating the replacement services in APIM, Logic Apps, Functions, Service Bus, and Event Grid, and then removing those services from the legacy ESB and updating the systems that depend on those integrations.
So on the topic of serverless and integration, I've got another customer case study I'd like to share. And I think it highlights this shift away from expensive isolated services towards more multi-tenant VNet integrated services. And this architecture is heavily based on using logic apps to process a request coming in from the internet, do a bunch of transformation, and then pass that payload on to on-premise services. They used Azure Traffic Manager to load balance between Azure regions, and they used an application gateway with a firewall to be able to route traffic to either internal or external APIs with API management. And as I mentioned, it's heavily based on using logic apps to coordinate this workflow. And to do that, they used an integrated service environment, or what we call an ISE, to achieve this network isolation. And an ISE is just the logic app service running on dedicated resources and doesn't run on the multi-tenant tier. And in conjunction with this, they used Azure Functions and Service Bus, which is pretty typical to see in a integration setup like this. And for the network isolation, they used similar, again, private endpoints and network integration. But it's interesting here that they used in this case, Service Bus, which isn't serverless, but this company really didn't care about serverless. They didn't have any champion kind of beating the drum saying that they should, swap over to serverless and crusading for it. They were just really looking to use the best tools for the job, and a bunch of those happened to be serverless. And finally, to get back on premise.
I was going to say you've just got some grey boxes on your screen, so you just might want to stop sharing and reshare.
How's that? Has that gone away?
There's still one. Yep, top right.
Well, not sure if I'm going to be able to get rid of that one.
That one's fine. That's out of the way.
Okay. All right. I'll keep rolling.
Sorry.
That's all right. Thanks for pointing it out. So where I was up to, we're talking about these ExpressRoute. So they were using ExpressRoute to get back on premise. Thank you. So the flow here goes like this. Basically, they would get a request come in. It would go via API management, and that would then go through to a logic app that would put a message on the service bus. And then they would have another logic app that would be polling that service bus, waiting for messages. And then when it got a message, it would transform that message in conjunction with calling some Azure functions and then pass that downstream to some on-premise services. So, I mean, this is a cool demonstration of enterprise integration and using serverless logic apps and functions. But what I really want to touch on here is this ISE, this instance of the logic app service that runs on dedicated resources and runs separate to the multi-tenant version. Because it sounds great to have, this isolated version, but it's thousands of dollars of dedicated compute power. And if in the case for this customer, you don't need all of that resource straight away, or if ever, then it's going to be underutilized. And it's the opposite of serverless, and you can't just scale it to zero, and you're going to be paying for more than you can use. And at the moment, an ISE is really the only way to get that network isolation with logic apps. And to be able to get that VNet integration doesn't really exist on the consumption-based tier of logic apps. So what this customer is going to be doing, pretty much along with anybody who's using an ISE, is they'll be moving all of their logic apps into a function app. And as we mentioned, it's on the public preview, and run all of their logic apps on a function app to be able to run it in a more serverless manner. Now, there's another problem here with running things on a dedicated kind of resources like this. It's not just expensive, but also in the case of a region outage, it takes hours to deploy them. So if you have a region that goes out, if you want it to not take hours to be able to fail over to another region, then you're going to need to be in an active model, and that's expensive and more complicated again. So I think this is an example not only of more and more companies moving to those multi-tenant services with VNet integration for network isolation. I also think it's an example of more and more companies moving to serverless pricing tiers so that they can be able to, put up more services and also tear down those services more easily, not just for disaster recovery, but also for being able to deploy amongst all their environments, be it dev, pre-prod, and so forth, and for those blue-green deployments. And before I hand you back to Adam, I'm going to go on a small rant. I really hope that more of the companies that we work with, and as they get used to working with their security and network teams, get more practice securing these multi-tenant services with this network isolation, they don't just always default to doing network-based security and start to use more modern identity-based security where applicable. It's not always possible, but where they can, rather than always defaulting the other way. Because I spend hours in meetings every day, even yesterday, and taking up a bit of time talking about all this network stuff. It takes, it takes developer energy and time to do all of that extra networking. So not managing that networking, just like not managing the servers in serverless, is a way for you to be able to pick up some of that time and be able to move more quickly. So I'm always joking, people show me their serverless setups and architectures, and I say, well, it's serverless, but is it also networkless? Because, as important as all this networking is, if you don't have to do it, then sometimes it's easier not to.
Thanks, Duncan. So I'm going to talk about Kubernetes, and I've got really mixed feelings about Kubernetes. My Kubernetes customers are my very best stories and my very worst stories. I worked with a customer, and it probably started about 2 years ago, and they said, I want to do containers. If I'm doing containers, that means I've got to do Kubernetes. Therefore, I must do microservices. Therefore, I need a service mesh, and I need to use open source everything, and I need. And I felt like the handbrake, constantly telling them to slow down and to simplify. But that didn't work. The outcome of that project was the developers all ended up with very impressive looking resumes. But of course, the project wasn't a success. So that was very frustrating to see. On the other end of the spectrum, I had an education customer who needed to build a system to support thousands of concurrent requests. They had a really strong development team, and they're already running several core systems on PaaS. They wanted to improve their developer onboarding time. They were already strong on DevOps, but they wanted to improve their DevOps processes and move towards a microservices architecture. The approach that they took was to start building on AKS. But the first application they built was using the same core technologies and patterns that they were familiar with. They just did it on Kubernetes. They were massively successful. They actually went to production in 16 weeks after the project kicked off. Then they started to focus on moving towards microservices and incrementally adding cloud-native tooling and architectures, including running functions on Kubernetes. And I think that's a great strategy. My other interesting Kubernetes story is about a large engineering customer that I'm working with. The CIO had mandated an approach to completely avoid vendor lock-in, but the architects and developers wanted to get the benefits of serverless. So we worked with them around their technology choices. AKS for Kubernetes was an easy one for them. They also wanted to leverage Azure Functions as their preferred platform, as it fit in perfectly with what they were trying to achieve. So they get the benefits of serverless, running it in their cloud-agnostic Kubernetes cluster. And then they also chose to use Cosmos DB and SQL Server as their SQL servers. SQL Server can be run anywhere, and if they did need to move away from Cosmos, they realized that they could switch it out with MongoDB. And now that Logic Apps run on Functions, they also intend to start leveraging their Logic Apps. Start leveraging Logic Apps. They've been very successful, and they're building their 5th app on this platform, as well as lots of key integration scenarios. The key to their success was similar to their education organization. They implemented their chains incrementally, and they brought in experts who'd done it many times before to show them the right way to do things, rather than just trying to reinvent the wheel and work it out themselves. And that's really my number one big tip for Kubernetes is don't try and figure it out yourself or do it in a big bang. Where with functions and PaaS, you can just do a bit and work it out. The learning curve on Kubernetes is steeper, and on top of the development team that Kubernetes requires, you also require a core team to understand how to operate the platform, while the developers are off focusing on building the workloads. So we just wanted to call out a couple of things that are coming next.
And one of those big things we've mentioned several times, which is Logic Apps running on the function runtime, which means you can run them everywhere. This will probably be out sometime end of the year, early next year. But it's in public preview if you want to try it now. I think it's a really huge deal. I think we're going to see a lot of people who were kind of interested but not using them are going to use them a lot more. So I think Logic Apps and functions will become much more interchangeable, and people won't have to pay for any of these ISEs anymore. And also, another thing I think we're going to see happening next quite a bit is that we're going to see more and more PaaS services offer a serverless pricing tier. And we kind of mentioned this before with SQL and Cosmos and a bunch of these services now. So I think it's going to become more and more common to be able to just choose a scale to zero option for these services, which is great because disaster recovery and spinning things up and tearing them down will become super easy to do. So I think we're going to see that become much, much more common to see these offerings.
And the other thing that I'm seeing, and I almost put this in a case study because I've got a couple of customers looking into this, but it's not they're not quite ready to do it yet, is that everyone's getting into Kubernetes. So lots of vendors of on-prem hardware and on-prem systems are adding Kubernetes capabilities to their platforms. And what this means for customers is that their on-prem hardware investments just are getting the ability to deploy serverless. So I think we're going to see this more, and I think we're going to see this more and more. The other thing there is that we've introduced a new service called Azure Arc, and Azure Arc lets you attach and configure Kubernetes clusters inside or outside of Azure. So it lets you manage, deploy, and monitor all of your Kubernetes clusters from the Azure portal, no matter where they are deployed. So Arc for Kubernetes is still in preview, but we've got customers that are really keen to see it deployed.
And also for those who are fast on their fingers right now, we've got a bunch of free swag. So we've got about 8 bits of free swag here. So the first link is a link to our newsletter we would love you to check out. And the second one is a link to the swag. And there's 2 codes there, one for Dunk20 and one for Adam20. So I think the first 4 of each of those, if you're fast on the fingers right now, we'll send you out a bunch of swag. So I'll leave that up for a second for people to jump in. And good luck. Hope you've got fast fingers.
And we'll put it back up at the end in case there's still some left. But look, I just wanted you to, if you walk away today with just a few messages, I really hope they are is that serverless isn't cutting edge anymore. It's an everyday tool used by the enterprise. Functions go everywhere. If you can, run them on your serverless compute, but if you can't, stick them on-prem into Kubernetes or even on another cloud provider. Functions let you do serverless programming today, regardless of where you need to deploy. And the serverless conversation starts with security. You want it, like if you want to do serverless in the enterprise, you have to do it as a team, and you can't do it without security and infrastructure being on board. I really just wanted to finish with that. The awesome thing about serverless is that it brings agility. It helps you ship your code to production every day. We hope you've enjoyed our talk and that you're leaving with some tips on how to be successful with serverless in your enterprise. We'll hang around and take some questions. Feel free to reach out to say hi on the conference Slack, and thank you very much. If anyone wants to come off mute, if anyone's got questions or things they want to talk about, then I think we've still got some time.
Thanks for that, guys. I think Nelly had a question in the Slack channel.
Oh, hey, Nelly. In the Slack channel. I am. Duncan, do you want to jump? I'm sharing.
Also, I can read out the question if you want. Is it the one that's in here, Nelly? Just, or Nelly, do you want to come off mute and actually ask the question? I'll read it out then. Thanks for a great session. A few questions. Getting Azure Functions on container doesn't get away from some of the features. Doesn't it get away from some of the features of Azure Functions, log bindings, triggers?
Yeah, look, and there's definitely some compromises. But that's, it's this, all of this conversation is about compromises. It's we're either compromising between massive scale, cheap cost and agility versus locking down something. And that's, I couldn't fit the containers on Kubernetes functions piece into that same spectrum, because it's almost, I kind of feel like it's almost a parallel spectrum once you go to functions on containers. But it is all about trade-off. It's looking at there's lots of different places, and there's lots of different opportunities to run functions, and there are definitely different trade-offs depending on where you go and use them. I think the key is to start adopting that paradigm. And the other thing is, as a product, and there's so much investment in this ecosystem that there's definitely compromises, but we can see that the investment is going in there, that it's getting better and better, and things that are challenges today are less likely to be challenges in 6 or 12 months. But great call out.
Any other questions from the audience?
Look, I think if that's it, we're going to be hanging out on the Slack for the rest of the week. But everyone, look, thank you very much for coming along, and stay in touch. Say hi on the Slack. If you do come along and you've got questions around functions, or around serverless, or around Azure, Duncan and I, feel free to reach out. We're both on Twitter, and we're pretty easy to find. And if you're interested in building out that, working on that starter project, or you want some hand with that kind of getting that kind of started, reach out via the GitHub.
Yeah, William said, can you flash that slide up again? I'm not sure if that's possible, Adam. Totally love your help, William, if you want to come join us.
Absolutely. So
Tuesday or Wednesday morning, we've all been catching up. So anyone else who wants to join.
We're running a bit of a community stand-up with people coming in. We're just in the early days. But yeah, we'd love if people want to come along and be part of it.